Hello, everyone. Welcome to the Midterm 2 review. The Midterm 2 will be focused mainly on Chapter 3 and 4. So let's go ahead and look at the breakdown of those chapters and see what was important, what we saw, and what kind of skills we learned. So for Chapter 3 was on polynomial and rational functions. And we started off that chapter by talking about quadratic functions. And in particular, we talked about standard form. And we also talked about finding vertexes, so maxes and mins. And we also talked about finding roots, of course, which is a skill we've been developing for a while now. Also in Chapter 3, we talked about graphing polynomials. And we did this using end behavior and root multiplicities. Okay, and then we moved on. We started talking about dividing polynomials. Which was a very important skill. And then kind of using this, we were finding rational, real, and complex zeros of polynomials. So in doing so, we used a couple main theorems that kind of guided our search for zeros. The first one is the rational zeros theorem. Very important. Another one that we also kind of looked at was the conjugate zeros theorem. And we also talked about the factor theorem. There were a couple others, but these were the main ones that we've been using. And then we finished off Chapter 3 by talking about rational functions. And when we talked about rational functions, we were talking about zeros of rational functions. We also talked about finding their asymptotes. Oops. So those were vertical, horizontal, or slant. And then we were using this kind of information along with test points and such to graph rational functions. So that was Chapter 3. The midterm will also be focusing on Chapter 4, which was a little bit shorter. Chapter 4 was on exponential and logarithmic functions. And we started off Chapter 4 by talking about graphing these functions. And we also kind of touched, after we introduced exponential logarithmic functions, we kind of talked about compound interest. As a particular example of an application. And we also took a brief moment to mention particularly the natural, exponential, and logarithmic functions. So those were important. And then we also, some of the skills we were developing was going between exponential and logarithmic forms. So swapping between those can be useful, especially when you're trying to like simplify an expression or solve an equation. And then lastly, we finish off that chapter by talking about solving exponential and logarithmic equations. And some of the tools we were using to solve these equations was, exponential and logarithmic properties. And we also used log laws, which came in handy. Okay, I'm going to go ahead and go over another practice example. I'm going to talk about graphing a rational function because those problems can be clunky and difficult and easy to get lost in the weeds. So I'm going to go ahead and do another example of that, just so we can kind of see it again. So let's say I wanted to graph a rational function, something maybe that looks like x squared plus x minus 6 over x to the third minus x squared minus 4x plus 4. Okay, so first we want to go ahead and factor the numerator and denominator. So x squared plus x minus 6, that's a numerator. If we can go ahead and use like the AC method or whatever you like. I'm pretty sure this factors out to just be x plus 3, x minus 2. Fairly straightforward. And then the bottom, x to the third minus x squared minus 4x plus 4. I'm going to go ahead and factor this by grouping because it's a cubic and it kind of set up for that. So we can pull an x squared out of the first two terms, so we get an x minus 1. And you can pull minus 4 out of the second two terms, get an x minus 1 as well. We can pull that x minus 1 out. And we get x squared minus 4. That's the difference of squares. We know how that factors. So we get x plus 2, x minus 2. So now we can rewrite our rational function as x plus 3 times x minus 2 over x minus 1, x plus 2, x minus 2. Now you notice this is one of those cases where we have the same factor on the top and bottom. In particular, we have this x minus 2 on the top and the bottom. So we can go ahead and cancel those. So we can rewrite our rational function as x plus 3 over x minus 1 times x plus 2 for x not equal to 2. And that x is not equal to 2 because you can't plug in 2 to this function because that x minus 2 then goes to 0. And then you've got 0 in the denominator, and we don't like dividing by 0. That tends to break math. So there's going to be a hole at x equals 2. All right. So from this, we can gather some information. We know that this rational function is a 0 at x equals negative 3. That's the 0 of the numerator. We also know that it has vertical asymptotes at x equals negative 2, x equals 1. That's the zeros of the denominator. And then if we see the degree of the numerator is 1, which is less than 2, and 2 is the degree of the denominator. So this means that we have a horizontal asymptote at y equals 0. All right, so now we can start using this information to graph. So let's make our coordinate grid. Get an x-axis and a y-axis going. Okay, so we said that we have a 0 at x equals negative 3. So that's 1, 2, 3 right here. So we know it's going to cross the x-axis there, but nowhere else. And then we said we have vertical asymptote at x equals -2 and x equals 1. So x equals -2 is this right here. And x equals 1 is this. Okay. And then lastly, we do have a horizontal asymptote on the x-axis. We'll just denote that right there so we don't forget about it. Okay. So now we can go ahead and use some test points to see if the function is positive or negative or whatever point. So let's go ahead and let's just do this middle section right here first, just because it's the easiest, because we can plug in the test point 0. If we plug in 0 to a rational function, all the x's are 0, they'll go away. I think we get -6/4, which is -3/2. So it's negative there. So we can go ahead and put that into our graph. And that's kind of right here, and it kind of goes down towards the vertical asymptotes. Okay. And then let's see, let's go ahead and do this region over here, right? So let's go ahead. Now, you think, oh, let's plug in the test point 2. That would make more sense. But remember, we can't plug in 2. Right? 2 is not a valid point. It's not in the domain of this function. So let's just go ahead and go when we're out and let's plug in 3. Okay, that was weird. My Wi-Fi decided it would just kaput for no reason at all. So let's get back to what we were doing. We were about to plug in the point 3 to our rational function. So let's go ahead and do that. So we plug in 3. On the numerator, we get 3 plus 3, and over 3 plus 2 times 3 minus 1. So that's going to be 6/5 times 2, which I think simplifies to 3/5. So at 3, it's positive. So our rational function in that kind of region will kind of look like this. Okay. Now let's go ahead and do the last 2 regions, this one and this one, on either side of that 0. So there's actually a shortcut that we can take. Note that in the rational function, this 0 has multiplicity 1. So we can actually leverage that information to sort of figure out what it's going to look like. And I'll show you what I mean by that in a minute. Let's go ahead and plug in a test point -2/2. So this one right here. So if we plug in r is -2/2, I'll just plug in -5/2, just to kind of make the math a little bit simpler. We get -5/2 plus 3 over -5/2 plus 2 times -5/2 minus 1. That's going to be 1/2 over -1/2 times -7/2. And that simplifies to 1/7. So that's positive. So if we go back to our graph here, this is going to kind of look like this here. Now, because the 0 is multiplicity 1, we know it's just going to pass straight through. So it's going to be negative on the other side of that 0. So on the other side of the 0 is going to kind of look like this as it goes, the horizontal asymptote. And that's what the rational function looks like. Okay, so that's another example of graphing a rational function. Hopefully this review is helpful. The midterm will go live on Thursday, and let me know if you have any questions.